Good morning, guys. Welcome all of you. Very good morning. Very good morning, everyone. So, yes, so there are a lot of important things that we are going to discuss. But first of all, there's a very important news that I want to share with all of you. Yes, Ria, Mohit. All right, you're already plus students. But for those who will be watching this session, something really important. That is from August 22 to August 26, Unacademy Unlock, that is 20% off on CSIR UGC NET subscriptions will be available right from today. Right, so for the Plus and for the Iconic, we are having 20% off on using the same code Jagriti S Live. Alright, so you usually get a 10% discount, but we are in between these dates 22 to 26 you'll be getting a 20% discount on using the same code for CSIR net complete subscription on both the Plus and Iconic, right? So yes, very important, guys. For all those who have not joined Plus and who want to join, this is the best time between 22nd to 26th. All right, chalo. Also, as you all know that two batches are going on simultaneously. One is your detailed batch and the other one is a practice batch. So yes, there are many other batches too which you can follow up. All right, on Unacademy, and you can just visit my profile on Unacademy to check out what are the different courses that I have taught. Okay. And yes, don't forget to use the code Jagriti S Live. The dates are also important. 22 to 26 dates yaad rakho, guys. Okay, for these dates only the offer is valid. All right. And also, if you want to get timely notifications of the classes, please join this group CSINet 2022. I usually share all the class links over here, free class links and plus courses. Okay? Yes. So everyone is here. Everyone can hear me properly. Very good morning, Rajesh, Madhu, and everyone, guys. Yes. So, what are we going to discuss today? हमने थोड़े बहुत reducing agents करे हैं, right? Oxidizing agents a little bit. Yes, so what are we going to do today? I'm just going to give you a glimpse of the stereochemistry that is used in the reactions. Okay, so what's the important stereochemistry? Let's talk about it, guys. Reaction की stereochemistry को ही dynamic stereochemistry बोलते हैं. So what is dynamic stereochemistry? It is nothing is the stereochemistry of reactions. Stereochemistry of reactions. Within the reaction, what is going to be where the product is, let's say if you're having a reactant. All right, let's say the most simple example is, for example, you have a ketone. So whether the nucleophile, for example, lithium aluminum hydride I'm taking, so whether it is going to attack from above or from below, right, that is the dynamic stereochemistry which is taking place in the presence of reactions. What are we going to do? We are going to discuss some really important points of dynamic stereochemistry, right? And first of all, let's start with the carbonyl itself. Yes, guys, अभी ये जो carbonyl है, or let's say if I draw a carbonyl molecule in this way, you are having R, C double bond O, H. I have drawn an aldehyde. Okay. So tell me, if I make the nucleophilic attack on the aldehyde from above the plane or from below the plane, is it going to cause any difference to it? Yes or no? Is it going to cause any difference? Yes, Rajesh, physical chemistry 1 month में cover हो सकती है क्या? Revision you are talking about. देखो, first thing अपना मतलब वो clarity रखो कि आपको revision करनी है कि 1 महीने में cover करना है. और अगर आप प्लस कोर्स से रिवाइज करना चाहते हो तो आपको बहुत सारी चीजें एक्स्ट्रा मिलेगी जो आपने पहले नहीं पढ़ी होगी. ठीक है, बिकॉज द एजुकेटर्स आर फोकसिंग ऑन अ लॉट ऑफ डिटेल्स. सो इफ यू आर स्टडिंग फॉर फ्रॉम द प्लस कोर्स कि आप सोच रहे हो कि 1 महीने में फिजिकल केमिस्ट्री में प्लस कोर्स से पढ़ लूंगा या फिर रिवाइज कर लूंगा, तो लेट मी टेल यू बहुत सारी चीजें एक्स्ट्रा मिलेगी. ठीक है, सो हाउ आर यू गोइंग टू हैंडल दैट एक्स्ट्रा थिंग? या तो आप ऐसे माइंडसेट से पढ़ो कि चलो ठीक है, जो भी एक्स्ट्रा आ रहा है या तो मैं उसको पढ़ लूं या तो मैं उसको छोड़ दूं एक बार, क्योंकि अभी एग्जाम सामने है तो प्रैक्टिस करना भी जरूरी है, राइट? सो इफ यू जस्ट ज्वाइन प्लस और लेट्स से स्टडी फ्रॉम एनीवेयर जस्ट फॉर 1 month, so only revision is possible in 1 month if you have your own notes. आपने खुद के notes बनाए हैं और आपको पता है कौन सी चीज कहाँ है, उसमें limited concepts है. If you are adding a lot of things, then it is going to take more time, not 1 month, and फिर practice will be delayed. ठीक है, so focus more on practice and yes, you can revise as आप दिन में 8 घंटे पढ़ के भी रिवाइज कर सकते हो, not a problem, right? So yes, you can revise, बट डू इट सिलेक्टिवली. ठीक है, सिलेक्टिव रिवीजन ज्यादा जल्दी कवर होगी. नो, डोंट ट्राई टू कंप्लीट द होल सिलेबस एट दिस पॉइंट. ओके, यस, ऑल राइट. सो लेट्स मूव ऑनवर्ड्स गाइज. व्हाट वाज आई सेइंग कि ये जो कार्बोनिल है, इफ अ न्यूक्लियोफाइल इज अटैकिंग फ्रॉम अबव और फ्रॉम बिलो, इज इट गोइंग टू मेक एनी डिफरेंस? Is it going to give you different products? Let's see. Let's say the nucleophile has attacked from above and you are getting something like this. You are getting something like this. It is your OH और ये R group है above, or let's say the hydrogen group is above, for example, just for example, and the R is below. It is like this. ठीक है, और दूसरा product कैसे बनेगा? That is the OH is over here, the hydrogen is above, R is over here below, और ये nucleophile इधर है. So are these two molecules same or they are enantiomers? Yes, these two molecules are mirror images of each other, isn't it? These two molecules, they are mirror images of each other, and that is why the attack on the carbonyl has two possibilities. Two stereoisomers are formed. तो हम इसको क्या बोलेंगे? Stereoselective attack. Yes or no? It is a stereoselective attack. Yes, and it has enantiotopic phases. Absolutely, Mohit. अच्छा, अब एक बात बताओ. If let's say the R group is not a simple methyl. अगर simple methyl हो तो ये सारे different हो गए. All the four substituents are different. Our carbon is chiral. Very good. But if the R is already a chiral center, for example, if the R over here, it has some pH, it has a hydrogen, it has a CH3, let's say it is already a chiral center, फिर क्या होगा? What is going to be the relationship between the products? Will they be enantiomers? और will they be diastereomers or homomers? वो तो diastereomer हो जाएंगे ना. Absolutely yes, they will be diastereomers. Yes. So when the reaction will give you two diastereomers of each other, what will you say कि वो reaction क्या है? Diastereoselective reaction. Yes. Then you will say the reaction is diastereoselective, isn't it? So stereoselective तो हमें पता था that whenever you are getting two stereoisomers as the product, भले ही enantiomer और diastereomer, that is going to be a stereoselective reaction. ठीक है, what is selective and what is specific वो भी देखेंगे. Selective is one where you are getting a major and a minor product, but दो product बनेंगे. ठीक है, that is stereoselective. That is one is getting more preference over the other. अगर मैं बोलूं कि I am getting 75% of one diastereomer and 25% of another diastereomer. So the first one is getting more preference over 25%, मतलब the next one. इसलिए हम बोले selective. ठीक है, अगर 50-50% बनता then it would not be selective. When one product is getting more priority over the other but still two are forming, major minor की possibility है, that is when you say it is selective. Diastereoselective means diastereomers are forming. When do I say it is stereospecific? When do I say it is stereospecific? Stereospecific मतलब only 100% yield of one single product. 100% yield of one single product. That is when I say stereospecific reaction. Yes, only one pure product. अच्छा ठीक है. तो अब स्टीरियो स्पेसिफिक के अंदर हम ये नहीं बोलेंगे कि डायस्टीरियो स्पेसिफिक है. वाई? बिकॉज एक ही बनेगा जो भी बनेगा. सो वी वोंट से इट इज डायस्टीरियो स्पेसिफिक. नो, ऐसा नहीं सुना कभी. यस, क्या सुना है? डायस्टीरियो सिलेक्टिव सुना है. यस, राइट. डायस्टीरियो स्पेसिफिक नहीं सुना. चलो, सो वी विल टॉक अबाउट दिस टू अ ग्रेटर एक्सटेंट. let's focus on diastereo selectivity. Let's focus on diastereo selectivity. So what is diastereo selectivity? That is getting a major and minor diastereomer. मतलब कि दो diastereomer बनेंगे in which one of them is major, one is minor. ठीक है? Alright. So let's say I am talking about the reduction of a ketone. That is the easiest example to consider. मैंने ले लिया ये molecule pH, and guys, it is very important that you are able to convert nicely all the जितने भी ये Fischer projection, Newman projection, Sawhorse projection, the interconversion should be very smooth, right? It should not be problematic. Yes, basic चीजें एकदम. चलो. So how is this molecule going to be? मैंने Fischer projection लिख दिया. Let's say this is a benzoin. All right, मेरे पास ये क्या है? It is a benzoin. तो benzoin क्या react करेगा guys? I have a possibility of carbonyl reduction, so I'll be providing the lithium aluminium hydride. ठीक है? But first I want to write this into the Newman projection. तो कैसे लिखेंगे Newman projection? See, how is a Fischer projection written? You know this already. That on the vertical line, whatever group is there on the vertical line, वो कहाँ है? Below the plane. And whatever is there on the horizontal line, that is above the plane. Like this. ठीक है? So if you want to write a Newman projection, और Newman projection भी कैसा देखो, you have to put the carbonyl first. ऐसे. So you're looking from the carbonyl to this bond. आप इस bond के through देख रहे हो. So what will end up? This pH will end up below. OH will end up on the left hand side and this hydrogen is on the right hand side. You're looking from the carbonyl carbon bond. Carbonyl carbon bond के through आप देख रहे हो. Does it make sense? ये कैसे बनाना है? Yes, this is clear to everyone. R benzoin it is. Absolutely. Very, very important guys. ठीक है? Yes. Now what are you going to do? अभी मैंने provide किया nucleophile. What is the nucleophile? It could be lithium aluminium hydride और NaBH4 और ज़्यादा डरावना मॉलिक्यूल लेना है तो L-selectride. Yes, all of them are going to attack the nucleophile from the less hindered side without any doubt. कुछ भी ले लो इनमें से. So you are having a hydride attack which will take place from the less hindered side. Which one is the less hindered side, guys? यहाँ पे हम apply करेंगे Cramps rule. Yes, we will apply the Cramps rule over here. So the less hindered side is over here where there is small group present. Hydrogen is a small group. ठीक है? Yes. So यहाँ से अटैक कराए मतलब कि this bond is going to open up. What do you get? Let's write guys. क्या मिलेगा? The back carbon is going to be as it is. उसको change नहीं करना है. So let's write the back carbon first. ठीक है? And then next we are writing the front carbon. ये रहा OH और ये रहा हाइड्रोजन. So looks like you got a meso molecule, isn't it? ऐसा ही लग रहा है ना? First we will not rotate. No Mohit, see, there are two models, Cramps model, Felkinan model, whichever you want to do. Cramps model में ऐसे ही है. ठीक है? You can just keep the largest group in the bottom and medium and small. You can keep it like this. अगर Felkinan model देखना है, if you want to see the Felkinan model, then you have to rotate the carbonyl in this way. Yes, according to the Falkin model, ऐसे rotate करो and then check that when the nucleophile is attacking following the Burgide unit's trajectory. Burgide unit's trajectory क्या होती है guys? The angle of 107 degrees. You all know that already, isn't it? Yes. Burgide unit's trajectory, the angle of 107 degrees. ठीक है, तो न्यूक्लियोफाइल ऐसे ही अटैक करता है. सो देर आर टू पॉसिबिलिटीज. मैंने कार्बोनिल को रोटेट करा दिया ऑन द लेफ्ट हैंड साइड, ऑन द राइट हैंड साइड. सो यू हैव टू डिफरेंट पॉसिबिलिटीज. चेक करो, दीज आर करेक्ट, राइट? यस. अच्छा, तो द न्यूक्लियोफाइल हैज टू अटैक. अभी यहां से अटैक करेगा या फिर यहां से करेगा? एब्सोल्युटली फ्रॉम द लेस हिंडर्ड साइड. यस, सो डोंट फॉलो दिस, क्योंकि OH है यहाँ पे causing steric hindrance and यहाँ सिर्फ हाइड्रोजन है, so it will attack from this position. Okay, so what I'll do is मैं इसको erase कर देती हूँ and then we will follow the one that we have written over here. ठीक है, and we'll see that from the Cramps rule and from the Felkin-Ahn model क्या हमें same product मिल रहे हैं. Let's see. So let's say I have made the attack from here. Okay, nucleophile is our hydride, तो hydride बन के क्या आएगा? The back carbon is as it is. Yes, ठीक है. Yes, the back carbon is as it is. क्या करेंगे? You have pH and since the nucleophile is attacked like this, ये oxygen को हम नीचे भेज देंगे ऐसे and we will write the hydrogen over here. Yes, now you rotate a little bit. What do you see? थोड़ा सा rotate किया तो देखा that is it giving the same product as the Cramps rule? Absolutely it is. Same. So this thing we are following through the Felkin-Ahn model. Felkin-Ahn model. Yes. ठीक है, ये Felkin-Ahn model से मिल गया. And this way you are seeing from the Cramps rule. But ultimately our goal is to get the most stable, मतलब कि product, जैसे कि the nucleophile is going to attack from the least hindered side. That is our goal. वो कैसे भी कराओ चाहे. ठीक है, so whichever you want to follow, it's the same thing. Okay, so yes guys, अब ये जो product मिला है meso product. So here meso is the major product. This is going to be the major product. Yes, so क्या हम ऐसे बोले कि इस साइड से अटैक ही नहीं होगा? That is, can we say that the hydride will not attack from this side at all? Should we say कि ये 100% इधर से अटैक करेगा? No. Why? Because OH is like it is sterically hindering the nucleophilic attack, but it is not very bulky. तो कुछ product यहाँ से भी बन सकता है. The hydride can attack from here also. Yes, but that will be your minor product. That will be your minor product, and this side, the red side, it is the major product. तो हो गया ना diastereoselective. Why? Because if you are making the attack over here, देखो क्या बनेगा? Find out what are you going to form? If the product forms from here, guys, let's see क्या बनता है. You have pH, you have OH over here and a hydrogen. और ये pH मैंने इधर लिख दिया. And the hydrogen is over here and the OH is over here. Guys, you are getting a enantiomer, basically a optically active molecule. अगर यहाँ से hydrogen attack किया, so you are going to get an active molecule. Yes, active molecule. So what is the relationship between the active molecule and the meso molecule? These two are diastereomers of each other. आइए, और diastereomer के अंदर meso diastereomer is major and the active diastereomer is minor. तो इसीलिए ये reaction है diastereoselective reaction. It is a diastereoselective reaction. Yes, this makes sense to everyone. All right, we have studied a lot, guys. Let's apply the Cramps rule to more molecules. ठीक है, Cramps rule is super important. ठीक है, चलो. So we have another example. दूसरा example लेते हैं, but there is some problem over here. क्या problem है? It's not a simple molecule. There's a Cl, there's a hydrogen, CH3, like this. ठीक है, so if we want to, let's say, if we want to form the, if you want to do the Cramps rule over here, Cramps rule को apply करके we will see कि कहाँ attack हो रहा है. No problem, we can do that. But हमने reagent लिया है NaBH4. बट इसको ड्रॉ कैसे करेंगे गाइज? आर वी गोइंग टू ड्रॉ इट इन द सेम वे जैसे हमने पहले ड्रॉ किया, दैट इज पुट दीज क्लोरीन एंड हाइड्रोजन अबव द प्लेन, मिथाइल और कार्बोनिल बिलो द प्लेन, ऐसे ड्रॉ करो, डायरेक्टली ड्रॉ करो. ओके, it will not be a problem. Just directly place the Cl on this side, okay, and just directly place the hydrogen over here, और पीछे वाले कार्बन का मिथाइल आ जाएगा यहाँ पे. Yes. So now if you follow कि हमारे पास तो हाइड्राइड है, हाइड्राइड is our nucleophile and I want to make the hydride attack from the least hindered side. So this is the least hindered side, मुझे यहाँ से अटैक कराना, I'll get some product. Yes. ठीक है. Yes, I'll get some product. So what is the product guys? Let's see. क्या product बनेगा? OH is over here. There's a hydrogen on this side and this is CH. अच्छा, सामने वाले कार्बन पे C2H5 है, बैक कार्बन पे CH3 है. Just one second. Yes, बैक कार्बन पे CH3. Alright, so what do you get guys? इसको क्या बोलते हैं? Yes, when you are having both the hydrogens on the same side. Alright. It is the erythroisomer, isn't it? इसको हम बोलेंगे erythroisomer. When both the hydrogens you see are on the same side, both the alkyl group on the same side, both the substituents are on the same side, इसको हम बोलेंगे erythroisomer. Yes, but is it the product that we obtain? क्या यही product major मिलेगा हम लोगों को? Absolutely not. नहीं मिलेगा. Okay, ये नहीं मिलेगा. It is wrong. Why is it wrong? Yes, हमने तो Cramps rule follow किया ना. We are following the Cramps rule only, but this is wrong. Why? Because whenever you are having a heavy atom like this, heteroatom, heavy atom, ठीक है? So whenever a strong electronegative group like halogen is present, let's write quickly. Strong electronegative group like halogen okay, it wants to be placed opposite to the carbonyl. Why? क्योंकि उससे dipole moment ज़्यादा stable होगी, isn't it? So when a strong electronegative group like halogen is present, it has to be placed, मतलब there is no other option, आपको रखना ही पड़ेगा इसको. It has to be placed opposite to carbonyl. Why? देखो, so the conformation is correct. ठीक है, so we will just continue with the same conformation. थोड़ा सा changes कर देते हैं. That is the hydrogen over here and the CH3 over here and the Cl over here. Yes, why do we have to do this guys? Yes, Cl should be down, मतलब opposite to the carbonyl. ऐसा क्यों है? Because carbonyl, the oxygen is electronegative, वो भी क्या कर रहा है? Electron pull कर रहा है, right? And over here, this chlorine is also pulling the electrons, so that is why the overall dipole moment of the molecule would be minimized, and that is going to give rise to a stable molecule, isn't it? तो अगर नहीं तो अगर ये molecule रहेगा हमारे पास, ये conformation रहेगी, all the electron density of the molecule is accumulated on one side, that is a destabilized molecule and this is a stable molecule, right? So this conformation is more stable. अब यहाँ से follow करो. Sodium borohydride, let's say you are having a hydride over here, so it's going to attack on this side, absolutely less hindered side है. How is it going to be? लिख दो C2. Alright, so and in the back you have a Cl, you have a hydrogen and the CH3, and C2H5 is above OH is like this और A किया गया hydrogen. So yes, is it correct? Check once. Yes, ये correct है. लेकिन इस तरीके से लिखना नहीं है मॉलिक्यूल को. लिखना कैसे है guys? Always try to write the molecule in such a way that the alkyl groups are together. ठीक है? The reaction is correct, but we are not going to compare in this way. जो nomenclature आता है हमारा trio and erythro, that is based on similar groups ending on the same side. That is the alkyl group. Always try to take the alkyl on the same side. तो इसको कर दो rotate, and then you will see the Cl goes over here. यहाँ से ये Cl ऊपर चला गया and the hydrogen will come over here. I'm just rotating the back carbon, right? Yes. तो ये क्या बन गया? It is a trio isomer. So trio is the major product. Yes or no? In this situation, when the Cramps rule is not followed, यहाँ Cramps rule follow नहीं होता है, और you can consider this an extension of the Cramps rule कि Cramps rule के अंदर और conditions आ गई कि भाई stereo electronegative electronegative group है, so it is going to have a different conformation. This conformation is more stable, just that. ठीक है? And it is going to give you trio. So once again, dia-stereo selective क्योंकि erythro and trio are also diastereomers of each other. दोनों diastereomers हैं. ठीक है? Yes. All right. Very good. चलो फिर we have one more example to consider. One more very important example to consider. That is, ठीक है, हमें पता है Cramps rule कैसे अप्लाई करना है. ठीक है, and now we have seen two examples. So एक और example देखते हैं guys. How is it going to be? Let's say I am taking the same molecule pH, OH, CH3 and the carbonyl and the pH. ठीक है, ये मेरा molecule है for example. ठीक है, all right. So what I'll do is OH हो या कुछ भी हो, doesn't matter. मैंने एक न्यूक्लियोफाइल ले लिया, let's say CH3Li. Alright. So what will happen is guys, there are some metals. अच्छा, see in the first example here, if I'm taking lithium and lithium L selectride LiLH4, this is going to cause a difference. NaBH4 तो नहीं करेगा difference cause. ठीक है, so इसके लिए जो है, इसे हमें erase करना है यहाँ से. क्यों करना है that I'll tell you. Lithium is going to cause a difference. Yes, right? What is that difference? The difference is lithium is going to chelate. Yes, Mohit, what is your comment? We name them as LMNS, right? Always L should be down. Yes, in the Cramps model, L, the large group, that is supposed to be down. Usually when you are doing the Cramps rule, अगर electronegative element आ गया जैसे कि chloride, fluoride, any of your halogen basically, if it is like highly electronegative halogen atom, उसको भी हमें carbonyl के opposite रखना है, just that. Just keep it opposite to carbonyl. Other than that, if you want to mention the large group or the medium group or small group, वो आप कर सकते हो, not a problem. And why it never helps me to write large, medium and small, क्योंकि मैं कभी वो शॉर्टकट से नहीं जाती हूँ. मैं मॉलिक्यूल की शक्ल देखती हूँ कि अच्छा ठीक है, इसमें कौन सा मीडियम ग्रुप है. आउट ऑफ कॉमन सेंस आई डू द क्वेश्चन. ठीक है, वो जो शॉर्ट ट्रिक लगाते हैं ना हम लोग कि भाई ये लार्ज, मीडियम, स्मॉल है, इसको ऐसे रखो वैसे रखो, उससे ज्यादा कॉमन सेंस काम करता है. ठीक है, सी इट इज योर कॉमन सेंस कि आपने ये देखो, इन दिस क्वेश्चन इट इज कॉमन सेंस कि आपने क्या किया, OH को इधर रख दिया, H को इधर रख दिया एंड PH को नीचे ले लिया. तो लार्ज ग्रुप तो हम नीचे नीचे रख रहे हैं एंड देन स्मॉल एंड मीडियम विल अरेंज अकॉर्डिंग टू हाउ द क्वेश्चन इज. अगर मैं बोल रही हूँ कि आई हैव टू टेक द R benzoin, yes, I have to take the R benzoin, then this medium group is coming on the left hand side. If I say that I am taking the S benzoin, ठीक है, मैंने बोला कि मुझे S benzoin लेना है, so this OH is going to come on the right hand side. Yes, yes. So keep the pH down. Also, if it is strongly electronegative group, तो भले ही यहाँ पे CH3 हो या pH हो या कुछ भी हो, that electronegative element is going to come down, right? So उस टाइम पे वही उसी को ही नीचे आना पड़ेगा, that will become the large group, right? And what happens over here? This is the third scenario where we are actually having a chelating metal. Yes, why is this situation problematic if you just follow simple Cramps rule? क्योंकि यहाँ पे chelating metal है, this lithium, it is chelating in nature. ठीक है, so और कौन करता है chelation? Zinc करता है, zinc 2 plus, lithium plus, magnesium 2 plus. Yes, ये सारे के सारे chelating हैं. Chelation will happen. Okay, if I say sodium, if I'm using NaBH4, sodium is not going to chelate, right? So except sodium, we have zinc 2 plus, lithium plus, and magnesium 2 plus. These are all going to do the chelation. Acha. So you write the molecule once again in the same format. आपको पता है आपको कैसे convert करना है, but again I'm writing this thing just for the sake of revision. ये देखो. This is how the Fischer projection is written. So you understand that this is your carbonyl above and the pH is below. And on the back carbon, right hand side पे methyl, left hand side पे OH, और below the below group आएगा pH. This one is below. Right, very well. So if we do the attack from the less hindered side in this particular conformation, our product will be wrong. क्यों? क्योंकि the molecule is going to exist in such a way that you keep both the OH and the carbonyl on the same side. OH को हमने कर दिया rotate. So the methyl comes over here and the pH comes over here. Why are we doing this? क्योंकि हमारे पास तो chelating metal है ना. Yes, LiCH3 you are having. Li plus नहीं लिखेंगे. If I have written a bond over here, I'll just write lithium methyl, right? Yes, so this is the chelation model where you can explain the attack of CH3 minus from the less hindered side, that is where the methyl is present. ऐसे करके हम करवा सकते हैं attack from the less hindered side. ठीक है, this one is the less hindered side because of methyl और ये more hindered side है. So once again diastasia selectivity is forming the major diastereomer. Back carbon is written as it is. Front carbon पे pH, OH and CH3. ठीक है, so ये मॉलिक्यूल है. बट इज इट थ्रियो और एरिथ्रो या फिर मेसो है या एक्टिव है, कैसे देखेंगे? जस्ट ब्रिंग बोथ द फिनाइल्स ऑन द सेम साइड, देन यू विल बी एबल टू चेक. क्या है गाइज, मेसो है कि एक्टिव है? यू टेल मी. एब्सोल्युटली मेसो, एब्सोल्युटली मेसो. ये तो मेसो हो गया. यस, सो you call it meso or you call it erythro, same thing. This is the major possibility, major diastereomer. Yes, ये major diastereomer है which has been formed. All right, very well. So where else do we have diastereo selectivity? Yes, कोई और reaction guys जहाँ हम और हमें और भी diastereo selectivity मिल रही है, और enantio selectivity? Yes. So when we are talking about addition to the alkene. For example, when we are talking about addition to the alkene, so guys, alkene ऐसे attack करता है ना, alkene is electron rich, it is going to attack on the electrophile, and for example, the electrophile is the bromine. How are you going to end up? You will have to write the molecule in this way. ये देखो, one methyl above, one methyl below, one methyl above, one methyl below, और ये bromonium ion on the plane of paper. ठीक है? So this is how you are going to get the intermediate. All right, very well. अच्छा. Now 1Br minus is going to attack from this side to open up this ring, and that is going to give you one isomer. अब वो isomer क्या है? वो enantiomer है कि diastereomer है? That we'll have to see. एक काम करते हैं. Let's say we write R1, R2, R3, R4 over here. Isn't it? 4 different groups we are having. तो ये हो गया R1, R2, R3, R4. So here this carbon is as it is, इसको कोई change नहीं हुआ. So R3 and R4 will be as it is. However, इस carbon पे क्या हो गया guys? Inversion. R2, R1. It is going to be like this. It is inversion, right? So yes, this is one molecule. अब मैंने क्या किया? इसको rotate कर दिया. And the eternal question कि हम rotate क्यों कर रहे हैं? हम rotate इसलिए करते हैं क्योंकि हमें देखना है what is the relationship between two different molecules. Okay, if we rotate from here, the R1 will become above और यहाँ पे R2 यहाँ आ जाएगा. ठीक है? Yes, students will always keep on asking, मैम why so much rotation? आप तो कर लेते हो, हमारा दिमाग खराब हो जाता है. Good morning Rolly. Another possibility is attack from this side. Yes. Yes, absolutely Vishnu, evergreen question. So you see, so see, follow the red one. अभी मैंने red attack करवाया है. So Br is going to come over here. This Br will open on this side. So where is the inversion? दूसरे वाले carbon पे. Here on the second carbon there is inversion. R3, R4. अब नहीं होता योगेश, अभी पक्के हो गए हो पढ़ के. चलो बहुत अच्छी बात है. So very good. So Br, R2, R1 और इस Br को कर दिया rotate. Why are we rotating once again? To compare with this molecule. Yes. So R4 is going to come above and R3 is going to go below. Now tell me guys, what is the relationship between these two products? दो different product बने हैं ना? One is the blue attack on this carbon, one is the red attack on this carbon. Yes, so what is the relationship between these two molecules? Are they mirror images, or they are enantiomers, or they are superimposable? Yes, गाइज दीज आर इनैंशोमर, इनको ऐसे आगे पीछे रखो ऐसे. ओके, प्लेस वन और उसके सामने रखो दूसरा वाला. ठीक है, लुक ओवर हियर. R1, see BR and BR are on the same plane of paper. Okay, तो keep the R1 and R3 and check. ये यहाँ पे below the plane है, यहाँ कहाँ है? R1 and R3 are above the plane. Okay, they are on the same side and they are above the plane, guys. So just keep two molecules in front of each other. You will know that they are enantiomers. Yes, है ना? See, bromination, guys, you know, bromination कभी diastereomer नहीं देता है. It gives you two enantiomers, right? And any kind of reaction जिसके अंदर की ऐसे 3-membered ring opening है, may that be epoxide, may that be aziridine, may that be iodonium ion or anything else, that is most probably going to give you enantiomers. Okay, and the phenonium ion, yes, you remember. Who doesn't remember? किसको नहीं याद है, उसकी पिटाई होएगी. ये देखो, the phenonium ion, right? So yes, whenever this kind of a ring opening is involved, you mostly will have the enantiomer. तो इसको क्या बोलेंगे? Enantioselective. Yes, याद है? बहुत अच्छी बात है. Very 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 good. Enantioselective reaction. All right. Very good, guys. Two enantiomers will be formed. Okay. Now, yes, one more thing. Depending on the nature of the substituents, the attack is going to be preferred कि कौन सा enantiomer ज़्यादा form होगा. Okay. मतलब कि you know, how are you going to be R1, R2, R3, R4? bulky कौन सा side है, less hindered कौन सा side है, right? That is going to determine the product. All right. And when we want to study कि what is the selective nature over here, the reaction mechanism involves anti-addition. किस टाइप का mechanism है? According to stereochemistry, it is anti-addition to carbon-carbon double bond. You are adding bromine from the opposite sides. Okay? कैसे पता करेंगे? ये देखो. Let's say you have cis alkene. Guys, this is very easy to remember. You have cis alkene. Okay? And let's say you have added bromine. So cis alkene के ऊपर, cis alkene पे anti-addition will give you DL pair. Okay? Cis alkene पे anti-addition will give you DL pair. Trans alkene पे, yes, trans alkene पे bromine addition, that is, it is also trans and we are doing anti-addition also, you are going to get a meso molecule. Meso, absolutely Mohit, yes, very good. और अगर मैंने करवाया cis alkene के ऊपर, if I am trying to do syn addition, let's say KMNO4 oxidation, क्या बनेगा? डायोल बनेगा. So cis molecule addition is syn addition, it is going to give you the syn diols, so you are getting optically inactive molecule या फिर meso molecule. Okay, and trans की possibility trans molecule reacts with KMNO4, that is syn addition, to give you once again DL pair. ये देखो, these are the 4 important possibilities for the selectivity on the based on the type of substrate as well as the type of addition. ठीक है? हाँ बिल्कुल ऐसे ही फॉर्म होगा. Yes, very very important all of these things. Yes. Any other example, guys? In addition, ka any other example? KMNO4 is one. And what about somebody else that you can suggest? Two groups adding on the same side of the alkene. Woodward cis dihydroxylation, absolutely. Alright, so Woodward cis bhi ho gaya. I'm just asking a simple reagent. Osmium tetraoxide. Yes, diol to osmium tetraoxide. Yes, absolutely. Okay, now I want to discuss one more thing with you all guys, but वो आज discuss नहीं करेंगे. We will discuss that maybe in the next session, or let me just see once. I wanted to discuss the effect of stereochemistry on some reaction. ठीक है, जैसे कि कौन सा reaction fast होगा, कौन सा reaction slow होगा. That also is very, very, very important. Yes, for example, see, yesterday only in the Battle of Pole, see, today also we have a stereochemistry Battle of Pole in the evening where we are going to practice numerical questions based on enantiomeric access. ठीक है, तो कल एक question किया था ना that the tosyl is like this below and the acetate is above. This is option number A and this is option number B. So which of them is going to do faster acetolysis? And what will be the product? Yes, we did this question. ऐसे बहुत questions आते हैं. It is not the only thing that we have to do. There will be plenty of questions like this. All right. Now, one more important example. Okay, let's look over here, guys. Yes, trans retention. So this was NGP. NGP is also going to give you two different products. All right, ऐसे वाले questions भी बहुत important है. तो पहले ये देखते हैं सबसे पहले. That is, I have an alkene in this way, exoalkene है. And this side I'm having the tertiary butyl group. What will happen when I'm adding metachloro per benzoic acid? What is going to be the major product? Yes, the metachloroperbenzoic acid, as you all know, it is going to transfer an oxygen, but where? Above or below? ये question है. Yes. And if I do the comparison, जैसे कि comparison वाले questions हैं. All right. Comparison वाले questions मतलब कि I have the same reagent the same substrate. एक reagent है metachloroperbenzoic acid. The other reagent I'm getting is peroxybenzimide. peroxybenzyamide acid. ये कौन सा एसिड है? peroxybenzyamide acid. It is made from the acetonitrile, alright, benzonitrile it is made from, और इसका फॉर्मूला है C डबल बॉन्ड NH. ये रहा, ये इसका फॉर्मूला है. ओके, सो yes, what do you think? It's easier to answer with comparison, क्योंकि with comparison you know about the reagent, which reagent is going to be bulky, इसलिए आप comparison करके अच्छे से बता पाओगे that where the metachloroperbenzoic acid will transfer an oxygen and where this benzimide acid, peroxybenzimide acid is going to add. Okay, just try this out. और just understand कि इनमें से less hindered कौन सा है, which is more hindered. First, that is the case. Benzimide above and metachloroperbenzoic acid below. More hindered. Guys, एक बात बताओ, ये मैंने C6H5 लिख दिया यहाँ पे, but then you have the same benzene ring over here and you have the same benzene ring over here as well. It is like this and it is a little bit bigger. ठीक है? This looks bulky. Peroxybenzimide acid is bulky. It is bulkier as compared to metachloroperbenzoic acid. Alright. तो ये क्या करेगा? Products are going to, both of them are going to give you epoxide. ये देखो. So, metachloroperbenzoic acid axial attack is favored. Axial attack favored मतलब कि epoxide goes above and the CH2 goes below. If it is favored, and peroxybenzimide acid, that is a little bit more bulky, if not much, a little bit more bulky is going to give you major product like this. तो इसका major product ये है that the oxygen goes above axial attack, और second reaction का major product ये है that is the oxygen goes below. ठीक है? Yes विष्णु, Cl bulky है absolutely, but Cl can stay away. हमें जो कार्बोनल moiety है उसके थ्रू हमें इलेक्ट्रॉन ट्रांसफर करवाना है यहाँ पे, right? That is the oxygen. So metachloroperbenzoic acid is slightly, it's found out कि slightly less bulky है as compared to this peroxybenzimide. Okay? Alright, we will try out one more example, that is let's say you have a reaction axial के ऊपर COCH3 present है and equatorial के ऊपर PH present है. What are you doing? Br2 CH3 COOH. आपके पास क्या है? You have only bromine and acetic acid. So what is this bromine acetic acid going to do according to you? क्या करना चाहिए? It is yes, it is going to give you bromination, alpha bromination, isn't it? That is ये वाला जो हाइड्रोजन है इसको रिप्लेस करके it is going to give you bromination. Just that now I'm asking you which one is going to be faster. Yes, alpha bromination, absolutely. So which one is going to be faster? ऐसा question आता है ना? Try to quickly draw the mechanism, guys. ठीक है, how are you going to do this reaction? वो करो पहले. Second is going to be faster. चलो देखते हैं. Intermediate is same. We'll see, guys. We'll see. चलो आ जाओ फटाफट. So what happens is, first of all, what we want to do is we want to do the enolization. यही करते हैं ना, in the presence of acid you can do the enolization. So when you want to do the enolization, this pH is over here and एक बनाया double bond and OH and CH3. This is how you do this mechanism, right? ऐसे ही करते हैं. Yes or no? This is how you do the mechanism, and now there will be bromine, so bromine attack is going to happen. हो जाएगा reaction, ठीक है. But एक बात बताओ, when you are trying to do the enolization, yes, okay, you are focusing on COCH3. अच्छा, उसमें तो stereochemistry कहाँ है ना मोहित? ठीक है, हमें तो पंगे लेने हैं, तो stereochemistry तो इधर है, right? So yes. So more substituted enol also you are going to get. So this enol is going to be more stable. Acid के presence में we always form the more stable enol. Yes, always thermodynamic enol is going to form. और base में we have a choice कि LDA ले लो तो kinetic और NaOH या methoxide ले लो तो thermodynamic, right? So yes, in acid we always get the more stable enol like this. So the question is कि intermediate तो same जैसा लग रहा है. Intermediate is looking like the same thing, right? So you will just have one O minus, OH minus या फिर OH and CH. This is what you have, same intermediate लग रहा है, isn't it? But the thing is, do you remember that CSIR NET में एक question आया था, which is the most stable conformation of this molecule? ऐसे आया था ना एक question? Yes, where is this methyl going to be? ये ऐसे ज़्यादा stable होगा या फिर ये ऐसे ज़्यादा stable होगा? Methyl over here. अब इसमें बहुत से स्टूडेंट ने रॉन्ग किया था. Why? Because you say नहीं नहीं मैम इक्वेटोरियल में स्टेबल होता है. मिथाइल will be stable in the equatorial, right? But then what happened? इक्वेटोरियल में तो steric repulsion है, so it is more stable in the axial, right? So same logic we are going to apply over here. What happens is, yes, so what happens over here is, see, in this intermediate, in this particular intermediate, because of repulsion, क्योंकि ये भी equatorial चला गया, this is also equatorial, so repulsion अनस्टेबल इंटरमीडिएट, बिल्कुल भी स्टेबल नहीं है इंटरमीडिएट, राइट? So what we will try to do guys, if we are keeping this one single conformation तो ऐसा ही intermediate आएगा. So that is why we can do the flipping. हम क्या करेंगे, flip करा देते हैं. After flipping, अच्छा sorry, ये रहा. Alright, so after flipping this COCH3 was above, so it stays above only, and the pH goes above like this. ये ऐसे ऊपर चला जाएगा pH. Okay. So now you can try this out because this pH is axial और आप बना दो यहाँ से OH करके NCH3 करके, you do whatever reaction you want to do and the product is going to be, where will the Br go, मतलब कि where is the bromine going to go in this particular molecule, right? Bromine is going to go below. ठीक है, यहाँ से अटैक हो सकता है ब्रोमीन क्योंकि above side तो फिनाइल रिंग है. So we can say that you have COCH3 and the bromine goes below like this. ठीक है. So alright guys, this is the product. ये product बन गया यहाँ पे. That one phenyl has to go axial, more stable possibility. Okay. So मैं ऐसे लिखेंगे more stable conformer and this is the major product from here. Alright, very good, well done. अभी इस पे चलो next वाले पे. इंटरमीडिएट को फ्लिप नहीं कर सकते, इंटरमीडिएट को भी फ्लिप कर सकते हैं, राइट? इंटरमीडिएट को फ्लिप करोगे तो ये तो ऐसे का ऐसे रह जाएगा. एक्चुअल में इट्स डिफिकल्ट टू शो यू इंटरमीडिएट फ्लिपिंग क्योंकि मैं ऐसे बोलूंगी दैट दिस कार्बन विल बी एज इट इज तो बोलेंगे नहीं मैम ये तो आप गलत करवा रहे हो. सो आई जस्ट डिड द होल मॉलिक्यूल फ्लिपिंग, राइट? बिकॉज अल्टीमेटली दिस इज sp2, राइट? इट इज नॉट गोइंग टू फ्लिप. कौन फ्लिप करेंगे? रिमेनिंग वंस विच आर sp3. So this will be as it is and the phenyl will flip like this. Okay, so it's the same thing. आप कैसे भी flip करो, ठीक है? अच्छा, so see in this possibility ये वाला हमारा intermediate आया. Yes, in this possibility we have an intermediate like this. Okay, very well. Now what are we doing guys? ये तो unstable है, right? The equatorial one, the di-equatorial one, absolutely unstable. We will try out another possibility. We will try to flip this molecule. pH, ये देखो. So ये दोनों के दोनों क्या हो गए guys? Both of them will become diaxial. ठीक है? See what just happened. Let me just mention what I am discussing over here. In this, stereo, in this conformer, in this particular conformer, ये pH और ये COCH3, both of them have become axial. दोनों के दोनों axial हो गए, which are big bulky groups. So guys, definitely there is a steric hindrance. No, there is a 1,3 diaxial interactions that we have not been considering till now. ठीक है? तो इसमें देखो, only this pH is going to go above, and here what happens is, yes, only one pH is going above or axial, and the other one is stable. Here, both the pH and the ketone, both of them are going axial. तो ये हो गई बहुत ज़्यादा unstable possibility. If this is unstable possibility, the reaction will be very slow for this. ये हो जाएगा slow, not fast. The first one is fast and the second one is slow. Why slow? उसको हम इसका intermediate बना के check कर रहे हैं. First form the enol or the enolate, right? And then just try to see the position of the pH group. So there will be very slow reaction over here or almost no reaction. ये intermediate भी unstable है और ये वाला भी unstable है. All right. So yes, no reaction. Absolutely very good. Yes. So I just hope that this makes sense to all of you. बहुत ही अच्छे अच्छे example करें guys, and there will be more examples that we will discuss tomorrow. Yes. बहुत बहुत अच्छे examples है. Yes, all right. This will give CH3 bromination. Yes, Mohit. So ultimately, it will give CH3 bromination. लेकिन it will also give you this as the major product. This one. इसके लिए तो मना है ही नहीं ना. This will form. Right. Stable goes through stable enol, and ठीक है. Major product is formed. Br is going to go below, and this bulkier COCH3 stays equatorial. ये possible है. This is not possible because both the intermediates are unstable. ठीक है? Yes. So guys, और भी question discuss करेंगे in the next session. Till then, enroll in the free mock test also. I have also informed you 28th of August को free mock test है. Yes. And the timing will be 10 a.m. Everyone has to attend that mock test and just try out your best. Also guys, बहुत अच्छा offer चल रहा है Unacademy पे. That is, you're getting a 20% discount on using the same code Jagriti S Live for 22 and 26th of August. In between these dates, basically, for both the Plus and Iconic. ठीक है? चलो guys. So if you need to know anything else about the offer, you can message me on Telegram. And bye everyone guys. We'll see you like super soon within 2 to 3 minutes on Unacademy Plus.